In this video, I will explain you the concept of photon. Now, so far we have learned about photoelectric emission, and photoelectric emission is possible due to the particle nature of light, because light behave as a particle, and this particle when collide with the electron, what is happening? The electrons are able to come out, or electrons are emitted from the surface of a metal. This process is called as photoelectric emission. Now, these particles by which the light is made up of is called as photon. So, we will see 7 very important points about photon. First thing is, in radiation matter interaction. What is radiation matter interaction? A light comes, so this is radiation, and that is going to interact with and electrons of a metallic surface. Okay, so this is radiation matter interaction. So in a radiation matter interaction, radiation act as if made up of particles called as photon. So in that interaction, this radiation behave as particle made up of photon. Okay, so this photon when interacted with the electron are able to take electron out of the metallic surface. Okay. Second point, photons are thought to be particles containing energy. So these particles that the photon carries certain amount of energy. This photon has a frequency, because these photons when in radiation they are moving in the form of waves, and this waves, so obviously in waves it will be associated with the frequency and wavelength. Now how we will get the energy of a photon? This one is very important, h nu. The photon is moving in a space in the form of wave, and this is having a frequency of mu, and the total energy associated with the photon is equal to h into mu. And mu can be written as, this is frequency is equal to c by lambda, so hc by lambda. So this is another representation. Next point, whatever may be the intensity of photon of a given frequency that have the same energy. Now this is very important. See, now I have two different power source. Higher intensity means it is giving out more number of radiation. So here in this case 5 radiation. Lower intensity means number of radiations are less, 3, 5. So this one is having higher intensity compared to this. But each and every radiations of this will be having the same frequency, because energy is a function of frequency. We have learned this. Now green color bulb, either it is intense power source or less intense power source, irrespective of the intensity, the frequency of each and every radiation will be the same. So frequency of each and every radiation will be the same, which means energy associated with every radiation is the same. So here the energy associated with this frequency is h nu, this one 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 is h nu. All the radiations are having the same frequency nu and the same energy h nu. Here in this case we have only 3 radiation with energy of h nu, but individual radiations are having the same energy h nu. Okay. Now see, obviously why there was having, we were able to get different amount of current with different intensity. We have learned that when we are increasing the intensity, the current will increase, right? Because see, we have 5 radiations here. So these 5 radiations, these are photon moving, right? These 5 photon moving will be able to take 5 electrons from a metallic surface. So number of electrons are more. Here in this case, this will only be able to take 3 electrons from a metallic surface. So this represents more number of photoelectric emission than this. Okay, this is very important. This one is more number, this one is lesser in number. Higher number of charge, current will be high, because I is equal to Q by T. Now the value of charge will be more with higher intensity, and that will be less with lower intensity. That is the reason for higher current when we are increasing the value of intensity. By increasing intensity, number of photon increases, 1, 2, 3, 4, 5, here 3. Intense, less intense. Okay, photon increases, but energy is the same. So energy h nu is the same. Energy associated with all the radiation, it is the same value h nu, but we have more number of radiation with high intensity, but here it is less. But the energy of each radiation is the same. Now why the current is increased? Because more number of radiations can participate in photoelectric emission, but here when it is less intensity, then lesser number of radiations are available for photoelectric emission. Next point, photon travels with same speed. So whatever may be the color, it's the same thing with all the frequency and with all the wavelength. The speed of the photon is the same, 3 into 10 power 8 meters per second. But this speed will change whenever the medium is changed. I will cover that in the next line. In different medium, wavelength of photon changes, hence velocity. So we know that V is equal to F lambda. This one is very, very important. Okay. Now, whenever light ray move from one medium to another medium, for example, I am keeping a glass of water here. Okay. A glass of water. And I am allowing red color light to move from air, and that will move through the water inside the glass, and that will also come out. Now here also in air it will be red in color, even inside water the color will be red itself, outside water also it will be the same color. So whatever may be the medium through which the light is traveling, its frequency will not change. See, color will only change when the frequency is being changed. The frequency is the same thing. Okay, whenever light travels through different media. Now what is changing when it travels through different media? The wavelength is changing. So see, we know V is equal to F lambda. Now F is equal to V by lambda. Now frequency will not change, which means now in a media outside in vacuum, if velocity is 3 into 10 power 8, then lambda will be a value. Now when it is passing through a different media, value of lambda will change, but frequency should not change. So what will happen? Velocity of the light will be adjusting themselves so that this V by lambda is a fixed quantity, that is frequency. So velocity and wavelength will be changing whenever it is passing through different medias, but frequency will be the same thing. So F is equal to V by lambda. This has to be constant. So if this is increasing, so the total value will decrease. To adjust that, this velocity also have to increase. So wavelength increases, velocity increases. Wavelength decreases, sorry, velocity decreases, wavelength also will be decreased, so that frequency is adjusted as a constant. Now in different media, yeah, I have covered it. 7th point, rest mass of a photon is 0. Now photon is coming with a velocity, so I have told you photon is a particle, so that particle will be having a mass. Now see, now I am exposing a material into sunlight. So if it is having a mass, on absorption of sunlight it should change its mass, right? So let's say photon is having a mass. Now these photons are absorbed by a material, so this should change its mass, right? But basically it doesn't happen, because the rest mass of a photon is 0. The moment it is being absorbed, its velocity comes to 0, its mass also will comes to 0. So these points are very, very, very important. Okay, thank you.